Future Forgers!
All right, another job here. Great, so we have 6 teams going today. You all know the drill. I don't see any guests. We got the teams here, the faculty here. So you got 15 minutes. Keep your eye on the time at me, then 5 minutes Q&A. First up, it's Future Forgers. All right.
Good morning, everyone, and welcome to Future Forgers' finals presentation for our game, Project Ecotopia. This is the Future Forgers team. Our faculty instructors are Heather Kelly and Jonathan Walton. Our faculty consultants are Ralph Latuccio and Ricardo Washington. Now, Project Ecotopia is a first-person narrative game set across 3 time periods that show the development of a rooftop community garden and builds to an optimistic and sustainable future. You play as visionary and eco-activist Miri as she recounts the impact she's had on her community over time. The game alternates between 2D interstitial exposition chapters and 3D interactive chapters to show 3 key points in Project Ecotopia's history. During the interactive chapters, players are having dialogue with characters, taking photos, and solving puzzles.
Our first time period takes place in 2015, back when Project Ecotopia first began, with teenager Miri and her mother Asha. In this section, you must work with Asha on the early stages of Project Ecotopia, helping to recruit people to your cause. Note that for this section, the visuals are a little bit darker to provide contrast with later areas. Now, to begin this section, players will find themselves with Asha on a mostly empty rooftop. Conversing with Asha uses branching dialogue to both give players the opportunity to express their own thoughts about climate issues and to inspire them to be part of a solution. After talking with Asha and joining the cause, players set off to create promotional material for Project Ecotopia. Players must explore the empty space to take photos, giving them the opportunity to imagine what these spaces could be used for in the future. To wrap up this section of gameplay, the player answers a few simple questions that explore their personal concerns with regard to climate change.
The second section of our game takes place in 2030 and is centered around one of Miri's proudest moments in her work on the development of the rooftop. In this section, the player must help find a compromise between Asha and the landlord of the building, Mr. Gideon, to share rooftop space, and this is based off of the real-life concept of agrivoltaic farming. So contrasting sharply to the first time period, this section takes place on a beautiful sunlit roof filled with solar panels, plant life, and numerous sustainability projects. After speaking with Asha and Mr. Gideon, the player sets off to design their agrivoltaic layouts. The player must arrange garden beds in the shade of solar panels, accounting for the sunlight needs of various plants. So as you can see, blueberries want full sun, collards want full shade, and carrots want partial shade. When a plant is positioned correctly, it will help to fill a food output bar. Puzzles have multiple sufficient solutions in addition to more challenging perfect solutions. This allows players to feel various levels of personal contribution to the rooftop. Here's a minimally sufficient solution, and here's a perfect solution. Players can also find the solutions to their puzzles reflected in environmental changes throughout the experience. Asha and Mr. Gideon are available on this roof to chat about puzzles and give feedback or advice. Speaking to any of these characters or investigating some of the environmental assets spread throughout the scene help give the player a wider community context.
Our final time period takes place in 2045, showing the next generation of Project Utopia with the introduction of Miri's child, Olive. In this section, you will navigate and explore the culmination of 30 years of dedication to the sustainable development of the rooftop. In this section, the rooftop has expanded to the adjacent building, showcasing new projects and new social spaces. After talking to Asha and Olive, you'll be tasked to take photos. This will serve as the method for showcasing the technology on the rooftop, such as vertical hydraulic farms and helix wind turbines, as well as showcasing that others had a contribution to these projects as well. Spread throughout the environment are small outlined interactable objects that trigger text, such as a chessboard or a shovel. These are in greater number in this chapter than in previous ones to show that others had contributions to these parts of the roof as well, other than the characters shown within the game. After you take pictures and talk to Asha once more, you'll head into the credits, where you'll see the images you just took, as well as the 3 that you took at the very beginning compared to the new 3 of the same views. At the end of the credits, you'll be led to the Get Involved button, which will lead you to our website. On our website, there is a list of community organizations that the player can join, quick actions that can be taken under 5 minutes, as well as further information about the technology you saw within the game.
Now here's why we think Project Ecotopia is unique. First, its optimistic tone rather than a dystopian tone. Second, it's based in realism, showcasing realistic technologies. And we also lean into sensory effect with polished and considered visuals. Now, after halves, we had to make some tough choices in order to control the scope of our game. The first of which was surrounding our puzzle complexity. Originally, the mechanic had 2 phases, one where you're placing planter beds and one where you're placing solar panels. This was too complex for players and led to UX complications that would have taken a long time to iron out and would have taken dev time away from other areas of the game. Our solution was to remove the second phase of the puzzle, leaving only the placing of planter beds. These simplified mechanics allowed us to iterate and refine on the smaller puzzle more quickly. It also reduced the amount of time it took to play our game, which made the game easier to test. We also recognized that our character budget was being exceeded by our character count. We originally wanted to have 4 3D characters in the world, but we realized from a modeling perspective that this just wasn't possible. So after careful consideration of the script, we decided to remove Eddie, the electrician character, as a 3D character from the rooftop. Now what this did is it freed up time to allow for more polish on the other more important characters of the script, and it also paired well with the removal of the second phase of the puzzle, because Eddie was the character whose NPC's interest was representing that second phase. Our key takeaways from our scoping decisions are we tried to remove things that were of low impact in the game, but high cost to the team. This helped to narrow our focus of IGDA tactics used down to sensory affect and systems knowledge. But these effects did trickle down into other areas, where mostly narrative, where major parts of the game had to be reworked to accommodate these scoping decisions.
Now, let's talk about how we use external feedback in order to improve on our design. We conversed with many external consultants in order to help iterate on our design process. In the pre-production stage, we talked with Keith Webster and Rob Hopkins, who helped provide us scenario planning and systems knowledge support in order to help build our world. We also had an ongoing consultation with Jessica Hammer, who helped us iterate on player experience, design for impact, and she also helped build our call to action. We also reached out to an experienced game producer, Lulu Lamer. She was able to play through our experience and helped us identify potential areas of concern, namely focusing playtests after halves on UX. So, about our playtesting process. Early on in the semester, we started out using PowerPoint click-throughs and paper prototypes. However, the major challenge with this was that even though it was useful for rapid iteration, however, it did not represent the visual impact of our game well, and the puzzle gameplay was devoid of context. In this later part of the semester, we started to test out individual chapters of our game. Now, this allowed us to reduce playtest time and allow us to test out more people. However, as the different sections were devoid of context, players were left confused about their position in the world and what their motivations were. Finally, towards the end of the experience, we started to playtest the full experience, and this gave us the most authentic data about how people truly felt about our game. What we realized from all our playtesting sessions is that it was difficult to understand what players truly felt about our game until we had fully playable builds available. So, combining all this feedback that we received, we were able to iterate upon 3 major aspects of our design. First, players were concerned that they were not able to connect the puzzle gameplay to the rest of the world. Our solution to this problem was to contextualize the puzzle through individual NPC conversations and also show the contents of the puzzle solutions in the game world. Secondly, many players said that they thought core gameplay elements felt tedious. Our solution to this was the addition of interstitial images in chapters 1, 3, and 5, and also the polishing of dialogue writing. This allowed the game to feel less text-heavy and allowed players to enjoy the experience of playing the game more. Secondly, we also iterated on the camera mechanic, which meant that instead of requiring players to stand in specific locations to take required photos, they were now able to stand in a much more varied variety of spots in order to take these photos. The photos also played a repeating role in the narrative, and they also feature in the credits that roll at the end. Third, many players said that they felt our rooftop community space felt lifeless and uninhabited. Since we had a hard limit on the number of 3D characters that would appear on the rooftop, we decided to approach this problem through environmental storytelling. A number of inspectable items have been spread around the rooftop, and this helps build up the feeling of a community space that is inhabited by many people and is in constant use.
Okay, next, we are going to talk about some changes we make to improve players' experience. First, we iterate a lot on our puzzle interface. We use distinct colors and shapes for individual species icon, and we change the mechanism into drag and drop. We adjust the difficulty of the puzzles and make it optional for players to reach the maximum food output. This allows some players to spend more time on navigating the environment or narrative if they want. We also iterate on our level navigation. We create several paths in the open area to guide them. And we also add new assets that is easier for players to look for. For instance, a camera icon can be seen when you are close. And balloons high up in the sky can show at the farther distance to show the approximate directions. And we also iterate a lot on our door texture and models, try to help players to distinguish which is not interactable or not, and leading them to the ending area. And after we imported all the environmental assets and blind textures, we experienced some frame rate drops during the gameplay. So we characterize these assets into different categories in different layers and different render zones. So when you're on the top level of the rooftop, you can only see the adjacent render zone assets and several scattering objects at the surrounding that we said that's always visible. And we also swap some of the foliage with the plants and vegetables which have way less poly count. Oh, sorry. Okay. The last major issue we changed is about camera mechanics. We changed the mechanism into gaze at the camera icon above the points of interest to activate camera. This allows players to choose what angle they like to take photos. When taking the photos, we also allow them to rotate to a certain extent to find better composition. And we minimize the crosshair and the UI on the camera to better see the environment.
To wrap up, let's revisit our goals that we had for this semester. Based on player feedback, we successfully created a game that was appealing, informative, and optimistic. The design tactics we use have proved effective in inspiring climate optimism and action in our players. If you want to see for yourself, the game is available now for download from our itch.io page with the link on our project website. Moving forward, we will continue to work with Jess Hammer and Elaine Fath from the Center for Transformational Play to help us in submitting our game to festivals. We've already begun preparing materials to submit to Indiecade, IEEE GameSig, and Games for Change. We want to again say thanks to everyone who has helped us along the way. Thank you. We are now open for questions. So when it came to writing out the narrative, to plan out the seasons for everything, we actually set specific times like throughout the year that also influence the sort of lighting and the plants available on those rooftops. The span from 2015 to 2030 to 2045 spans from the beginning of spring into summer, based on that sort of research. Yes?
Some nice pivots along the way. Is the game complete in your mind now? Or would you add more?
The game is certainly at a level now where we are ready for it to be released and for people to play and experience it and have many of the impacts we want it to have. In terms of whether or not the game is complete, it always feels as though there is more work to be done, but it is complete in our minds with regards to this. Yes? Yeah.
Yes.
So a lot of this was about having a call to action, and you get that by people going to that page at the end. Are there metrics on that page so you can only get there, that page, from playing your game, and then you can count how long are people dwelling there, what are they doing on that page, so you can see if your game is actually succeeding in this call to action?
So we don't have statistics on specific links within the page, but we can tell where people came from to get to that page. So we're able to tell whether they came from the game to get to the resources page. And we also have analytics within Itch.io that can tell us we have a number of downloads, and we can compare those downloads on a day-to-day basis on who downloaded the game and then came to our resources page.
Yes,
Chris?
I'm curious if you could share more info on why you chose an optimistic point of view.
We wanted to show an optimistic perspective for our game, very much because we are concerned about our own future, and we believe that a lot of people are. And so a vision of a positive direction might resonate with a lot of people, especially if we try to ground our game in realistic technologies and things that are actually achievable. It's much easier to sort of push people or inspire people towards change if they can actually have a picture in their head of the change that they want to see. And so that was our rationale with regards to why we picked an optimistic vision of the future. Yes, true.
You mentioned that your game is successfully achieving transformations. I'm wondering if you could speak a little bit to what in your playing and observations lead you to that conclusion.
Yeah, so in our playtest so far, we have noticed a large number of the players engaging with the space, engaging with the different technologies that are available, and even pursuing further research on their own in terms of looking into the different technologies. It's one of the reasons why on the resource page we include the links to all of the sources for those technologies available. Moving forward, we are looking to potentially get more quantitative data with regards to that in terms of pursuing further research with regards to the game. But at least thus far, it's based off of the qualitative observations of our playtests.
Time for one more. All right, thanks, team.
Okay, good morning, everyone. We are Team POV, and welcome to our final presentation. Today, we are going to talk about our project overview, our exploration phase, and one of our prototype named Swipe History, and at the end is our summary. So about our teammate, we got Lucy, Qiwen, Sharon, Tuesday, and Xinyi, including a producer, 3 UI/UX designer, and a solo programmer. Our instructors are Shirley and Ruth. Our project is a discovery project based on rapid prototyping, innovation, and documentation of new use cases utilizing the client, a matchless technology swipe video. And our final deliverable is that we have 65 plus pages documentation, 12 prototypes, and 2 interactive demos. So what is swipe video technology? Swipe video technology provides users a software to create videos with no limit to the number of the cameras and any form of the digital camera. And users can swipe to view the videos in multi-angle and 360 degrees. And also the videos can be embedded into any web pages or view in the link. Swipe Video has did a lot of work, including sports, fashion retail, film, performance, and video game contents. And this is one of the example that they did in the past. In the course of the golf game, the audience can view the different movement of the player from different angles. Next, please. So our client came to us and said he wanted to add more creative elements by using this swipe video technology. So based on the client's need, we decided to define our project goal was to explore innovative way to use this technology and record all the creative concepts that we explore to make a final documentation as our final deliverable. And now I will pass to Qiwen.
So I will introduce our exploration phase of this semester. Firstly, we spent 3 weeks to doing the brainstorming of how can we utilizing swipe video technology. And then by combining and refining the idea we get from the brainstorm, we spend 6 weeks to doing the prototype. And at the same time, we are trying to keep a bi-weekly playtest. And based on the playtest results we get, we spend 3 weeks to doing the iteration. And after all, we combine all these stuff into our final documentation, which is also our deliverable. So now let's look at in-depth. We firstly brainstorm 45 plus ideas. And when we try to categorize them, we notice that most of them are falling into the categories including entertainment, social and tech, education, and interview and playtest. So after communicating with our clients and instructor, we decide to do more prototype in these areas. Then we came up with 12 demos, and here are the screenshots that we did this semester. From the demos, we picked 2 to be further polished based on the feedback from our clients and instructors. So that we can have more detailed information so that we can include that into our final documentation. The one on your right is Swipe Nature. It is an educational game that aims to teach young kids around grade 3 about 3D thinking and also some basic knowledge of nature. And the one on your left is Swipe History, and I will pass it to Xinyi to talk more detail about it.
So Swipe History is centered on the idea of mixing archival and modern footage in order to create a new way of interacting with educational content. Our uploaded footage should showcase the process of an object over time, and we will develop a platform that allows users to interact with historical swipe videos. The reason we think swipe video is perfect for this prototype is that because the technology gives us a very easy way to develop educational and interactive content, and also allows users to swipe through time. And we did some research about this prototype. First, we visited some local landmarks in Pittsburgh, researched some Pittsburgh histories, and filmed some of our own experience using swipe video technology. And next, we did some competitive analysis on similar products for our website design. This is an example of Google Earth Engine. And in our design phase, we have completed our system workflow and low fidelity prototype. Yes, here we use some markers on the Google map to browse through landmarks. And on the left side, we have a left side list to display the landmarks in view, and we can also click through that as well. If we click through one of the landmarks, the swipe video content will be displayed in the center. And together with some introductions and timeline informations to facilitate swipe video content. Yeah. And next, in our playtest session, we have over 30 people and come and try our prototypes. And we showcase them our low fidelity prototype and some sample clips of our swipe video content. And after that, we ask them a few questions and let them fill out a questionnaire. According to our playtest results, we have around 89% people thinks our UI UX are easy to understand. And as we have observed that many our prototype is especially popular for people over the age of 30. And they think our prototype is a fun implementation of the swipe video technology. Also, some of them mentioned that they want to upload the footage on their own. They're saying like, this is a great way of learning the transformation of the different places, and this is a great tool for travel planning purpose. And some of the negative feedbacks like, the swipe video content looks like some PowerPoint slides showing historical photos. And according to the playtest, we did some changes in our iteration process. The first one, we added more opportunities for social engagement. Like we added some buttons for us to mark we have visited that place, or like this video, or we can leave comments down below for the landmark and the video. Here. And also, we did some timeline. We changed our timeline from only displaying information to make it clickable and navigate directly to the time on the swipe video. And also we polished the UI design and UX workflows. Next, we have Lucy here to talk more about our iteration process.
So for the technology part of this web development, we basically implement this web page using like front-end client-side technology, and we adjusted the position of element and also the placement of the entire page with cascading style sheet and HTML, and all the interactive part is implemented with JavaScript. So in this way, the users can drag and drop the map to find the mark we placed on the map, and also like click the button on the left to have the panel out to read the introduction of the history of a place of interest. And they also have a panel that contains the swipe video, so where they can click on the video and like swipe to see the different time of a place of interest. So why we would recommend the swipe video to further develop on this prototype is that firstly, like after analyzing the playtest result, we got mostly positive feedback from playtesters over 30. So we believe there is a great group of people that can be the potential user of this product. And also, compared to other competitor products, for example, the one developed by Google Earth Engine, we believe our UI UX is more user-friendly, as for example, the users could be a tourist that's new to the city, so they would have a little knowledge of where those places of interest are placed at. So since our product had the mark on the map, and also we have the panel on the left, the users can directly spot where those places of interest are and click on that so that they can quickly get a brief history of this city. And what we have learned from building this prototype. After building this prototype and analyzing the playtesters' response, we figured out we should add more elements of engagement into this prototype in future. For example, we can have pop-up quiz after they have read the introduction of the places. And also we should allow users to upload their own video
that they shoot from the places so that they can have more sense of engagement. And we believe we also should like gamify the entire experience. We should give users the milestone badge, for example, like how many places this user have been and how many videos they have uploaded. Since sourcing archival footage is like from same point of view is quite challenging, so we believe the mark should be placed and also the first swipe video should be uploaded by educational institutions and museums as they have a great source of archival footage. And then I'll hand it over to Tuesday.
Thank you, Lucy. So Lucy and Xingyi just walked us through an example process of one of our prototypes. But the last piece to that is our documentation. As you see here, this is a title page for one of our prototypes, which we just talked about. And it'll include an introduction, a project description, project goals, as well as a proposed demographic. Some other key parts of our documentation following the title page would be our process, any iterations, features we implemented, workflows, and for some prototypes, further research, and personas, as well as more informational structures. So for our conclusion, this is our overall conclusion for the whole semester and our end of our documentation. Basically, our suggestion for how swipe video should move forward is to possibly turn towards UGC or user-generated content, as some of our favorite moments and feedback we got from playtests is that people really want to upload their own footage and create their own swipe videos. But to support this, there needs to be some changes to the UI and UX, specifically with their swipe video camera application, which allows for a team of iPhones to synchronize. Otherwise, you have to manually synchronize, but some of the layout on the application isn't super user-friendly, so some of our prototypes actually address that. And finally, to build towards more features that support social engagement and collaboration, such as the like feature and the swipe video or swipe history prototype in the comment section, just further features that would support the collaboration. So our metrics of success were innovation, rapid prototyping, and documentation. We rapidly prototyped 12 different prototypes and did 2 interactive demos. We came up with 45 different ideas and then have 65 plus pages of detailed documentation. So this semester we learned that the organization of these concepts early on in our process was super important in making these decisions about which prototypes to pursue, partially because just the dynamic of our team, we had 3 UI UX designers and 1 solo programmer, so we really had to keep in mind and keep in scope of what could be possible for this semester, as well as wanting a wide range of explorations explored. So yeah, thank you to our faculty consultant, Carl, and to our faculty instructors, Cheryl and Ruth, as well as to Kay, Oda at Amatalis. Thank you. We're open for questions. Yes.
Yeah, with the history prototype, it seems like you switched out space for time, or is space still an element that you can swipe through in the history prototype?
So are you saying like in comparison to the Google Earth thing? Like that's from a top down?
What I'm trying to understand is when I'm looking at a picture of a place, is it specific to the place where the picture was taken and I can navigate space as well as time, or is it just time?
Currently it's just time, so the idea is that it would be from the same point of view. It would be a footage, and then you'd be able to easily see the change of that specific location. So you, like if you went to a location, you stood there and you were able to kind of precisely see the change of the location you're visiting.
Right, so there's not 2 different points of view of that location, correct?
Correct, yeah.
So that actually was I'll follow up with that, because you say getting the same point of view is difficult. Did you do some play testing where maybe what I'm looking at, like the point, is not the same point of view? And did your users say, no, we really want the same point of view for swipe to be more powerful? Why? Is that a requirement? Is that a necessity?
So we did do one prototype or one kind of exploration in that with creating content that was of the same location but of different point of views. So like the Shenley Fountain, I think was it. And just based off of
yeah, feedback that we got from playtests is that people didn't really understand why they would want to view from the different angles. They were just like, okay, well, I can just watch an edited video of this, but like it's more powerful to them if it was from the same point of view, so you can clearly see the change over time. So yeah. But that is something that we could implement further, is to have multiple kind of timelines of different point of views to be able to see that same change, but from different angles, yes. Yeah.
I'm curious if you have a sense of what things you discovered that your client was most excited to learn.
So our client really wanted to hear all the feedback, the positives and the negatives, based off like everything that we received. He was most excited about our exploration with the motion capture. We did a depth camera kind of mesh from using the swipe video, and then we made a pipeline to basically explain what he could do with the mesh, and then rigging it, and then having the end point. He's working with a team called Deep Demise in France, and they get biometric information from video. So being able to take that depth camera mesh and then combine it with the rig that's from the swipe video is something that he's really excited about. So yeah, that was one of the things. Yeah. Yeah. The other one is the swipe game, the swipe nature that we briefly talked about. So yeah, that was our second, yeah.
Time for one more. All right, thanks.
Okay, thank you. Thank you.
Wait.
Hi everyone, we're Team Pico Pico P, and we're a game about cybersecurity. I'm Tenga, and I'm the artist, UI UX designer, and I'm also the sound designer.
I'm Jeffrey. I'm a game designer and a co-producer of the team.
I'm Shitai. I'm the programmer and also the co-producer of the team.
I'm Yiming. I'm the programmer and game designer.
So our client is Pico CTF from CMU Cell Lab, and they are a free computer security education program. Hi, Evan and Megan. They are here. And this year's our target demographic is middle school and high school students. So this year's scenario is a little bit different. Traditionally, Pico CTF hosts a 2-week contest which users only have access to the game within those 2 weeks, which is kind of limited. Well, this year, they are going to host a 1-year-long platform to encourage users to solve those challenges on Pico CTF. And the topic this year is reverse engineering and binary exploitation.
So this is a short demo of our fundamental gameplay. Our player needs to help our character, Mochi, to escape from the cyber world. And in this world, we have different cards. They have types and values and can construct statements to control the behavior and attribute of objects. And the player needs to thoughtfully think about where they should place the cards to change the attributes and players of objects to help Mochi to reach the yellow portal here as the final destination of one level. As you can see, this is a pretty simple level. This is an entry level. But as the game goes on, the difficulty level of the difficulty curve of the levels will increase progressively. And levels like this, and this, and this will be shown to the players. And if the player gets stuck, no worries. We have a tip system to help the player get out of the trouble. And finally, if the player can finish all the levels, we have provided opportunity to help decorate the mochi and put their names on the leaderboard. And this leaderboard will be shown to all the Pico City players. This is our way to motivate the players to learn as much as possible from our games. And finally, we have made a private, no, not private, we have made a secret hidden room as an Easter egg to celebrate the 10th anniversary of Pico CTF. This is a character from Pico CTF 10 years ago. And now Jeffrey will talk more about the details on the game mechanics.
Okay, thank you, Sitai. Now let me walk you through more details about our core game mechanics and how we express the concept of reverse engineering. So as mentioned before, our core operations are hacking and modifying objects. For example, in this level, there is a stone blocking our way to the portal. And we can hack it to open up the panel with chips defining the property of this stone. Here it says the size is 16. And if we swap it with the chip of 5 from our bag and compile, it becomes small because now the size is only 5, so we can pass it to the portal. So with this concept set up, we can even let the players change more properties of the objects in our game. For example, we can change if a fence is blocking our way or not. We can change the color of the light from purple to yellow. We can change the pushability of a tree or a stone. We can also change the length of a bridge. So at this point, you might already noticed and started wondering, what do those symbols on the chips mean? Well, in real-world computer programming, it is common for us to encounter a piece of code with unknown variables or functions. And the process of figuring them out by comparing different inputs and outputs is called reverse engineering. So in our game, to simulate this concept, we use the symbols to hide the words on the chips. And it is the player's job to figure out what those chips are defining for the properties of the objects. For example, in this puzzle, we have a stone and a bridge. The stone has 2 unknown properties, a square and a triangle. And the bridge has 1 unknown property, a diamond shape. And here it says something about the bridge is 2. And if we observe, it consists of 2 tiles. So could that mean the bridge, the shape is defining the length of the bridge? Well, to find it out, we grab the chip of 10 from the stone, and let's apply it to the bridge. Well, now it just extended into 10 tiles. That proves our hypothesis. But one more problem is that the fence is blocking our way, and let's hack it. So there's one more unknown symbol. The triangle here is set to true for the fence. If we just recall, there was also a triangle shape on the stone as well. So let's get back to check. So here, the triangle symbol is set to false on the stone. And if we compare the stone with the fence, the only difference between them is that we can walk through the stone, but not the fence. So could that mean the triangle shape is defining whether an object is penetrable or not? Well, to find it out, let's grab the false chip from the stone. And let's apply it to the fence. Well, now the fence just became unblocking, just like the stone was. So we solved our problem and proved our hypothesis. So this is just a simple example of how we express the concept of reverse engineering. And throughout the gameplay, the puzzles and symbols will become more complex and challenging to the players. And next, I'll invite Tiange to talk about our art assets.
So for the art part, as the only artist in the group, I have created over 40 tiles for the environment and environment decorations. And for the object, we want to use some strong color for the interactable object because we want to make them to be stand out in the grayish environment. And we end up with using some high contrast color set, which is purple and yellow. And we want to maintain the idea of purple is bad and yellow is good throughout the whole game. I have also designed 2 sets of UI. One is in-game UI. You can see for the hacking panel, storage panel, card slot, and chips. The other one is the system UI. It has been applied to menu, loading page, pause and failure page, costume page, and also the leaderboard. Here are some of the accessories for the costume page. I have designed a whole bunch of hats and glasses, and users have full freedom to decorate their little mochi. There are over hundreds of combinations they might have. And for the last part of the art assets is the character design. Our little character has a 4-way direction with each of them has 4 pieces of images frame by frame to make it look like moving. And in order to make the character more vivid, I designed 2 states. One, the left one is fainted for failure. The next one is sleeping for pause. And the image on the right-hand side is the full body standing illustration. The original one was created by AI, and this final version was iterated by the artist, me, and also AI. And then Imi is going to talk about how the pipeline for AI generation.
Hi, let me introduce our AI generate our workflow. First, we use text-to-image generation, which means we use a sentence to generate a batch of image. We choose the image that we think have potential from this batch of image, and our artists modify the image to get our first version of character. We also use AI generation to iterate in the future, and we use our first version of character to put it into image-to-image generation, which means we generate new image based on our current image. And then this generation give our artists new inspiration and new direction to modify. So after repeat this iteration, we get our final character.
Thank you, Imi. Now I'm going to talk about the documentation that we're going to hand into our client as long as our game build. The first one is a user manual and a configuration file. If you remember our tip system, it is exposed to our client so that they can just editing a JSON file to change the content that we want to show to the players. And also another spreadsheet about all the levels and what are the topics the levels are covering so that the client knows which tips they want to apply to which level. And now I'm going to talk about some of the iterations that we made during the game. As you can see, this is our original proposal. We have been inspired from Baba Is You to use statements to control the behaviors of objects, and also we want our player to have the ability to hack and modify objects. And now, this is what we have for the interim. We have spent most of the time working on the game mechanics, and we have built 2 reverse engineering levels and a very simple UI. And this is our final build. We have 20 levels in total for all players from different backgrounds to have fun. And also we have a complete world build with a character, with the simple but meta-style story, and also an event-driven conversation system, and also an Easter egg. And also we've developed a lot of supporting features like a customizable costume system, the leaderboard, and also the tip system to help the player throughout the game. And this is an example of the iteration we made during the game. As you can see, this is what we have for the interim. This is a level, so the player needs to just drag one card from the stone and put it in the bridge to change its length. And now this is what we have for our first iteration. After the interim, we have changed the layout of the map so that you can see the background and foreground are distinguished in a more clear way. And also, the player has a more clear sense of which direction they should go. And this is our final iteration. You can see that we have used colors to make the objects pop out from the background. And also we are using different colors to distinguish different types of objects. And also we've added animations to make the game experience more fun to play. And this is another example of how we do the iterations on the UI too. And we are doing the iterations based on our game design and also the feedbacks from the playtest. Speaking of playtest, I'm gonna let Jeffrey to talk about what we have during the playtest.
Okay, thank you, Suzanne. So throughout the semester, we conducted a lot of playtest sessions. We went to 3 different high school and middle schools. We did bi-weekly playtests at Han Library. We also, not to mention about the ETC playtest day. And in total, we had over 10 sessions of playtest with over 50 people that played our game. So here are part of the data that we collected on the ETC playtest day. And here are 2 questions, just part of our question that we asked our players. So we asked them how they thought about learning more about reverse engineering and binary exploitation. We asked these questions before they played the game and also after they played the game to do the comparison. So the purple bars are the result that they answered before they played it, and the yellow bars are the result that they answered after they played it. And if we compare those bars, we can see a general positive shift from thinking the game is thinking the topics are difficult into thinking the topics are easier to learn and solve. So that proves our game is changing their attitudes toward those intimidating topics. As for client, they thought we did a good analogy of both topics of binary exploitation and reverse engineering, and also they really like our leaderboard and avatar system. And they also thought we reached a reasonable balance between gameplay, story, and art. As for some quotes from the faculty from soft opening, they really like our art, character designs, as well as the appealing puzzles design. And next, I invite Yiming to summarize our project for us.
Thank you, Jeffrey. So let me talk about the lesson we learned. The first thing is that we find out difficulty control is pretty hard. And the second is that the educational game design is harder than just making a game for fun. And the third is that we find out that interaction detail is hard and very important, and it needs a lot of iteration. And this is the things we did well. The first thing is that we did not limit to our own role. Like Jeffrey also did a game designer, and Tiange also did a sound designer as an artist. Second is that we focus on milestone and goal spike. We make our paper prototype and electric prototype in the early semester, and which help us focus on our gameplay. And the third is that we find out that playtesting and rapid iteration is pretty helpful. And here is the summary. Mochi is again for helping primary school and high school students to focus on cybersecurity. And second is that the goal is to make the competition's targets approach to the participant. And third is that we complete the game and get positive feedback from our client and faculty and players. Thank you.
Hi. So you mentioned that both the UX part and the educational parts were difficulties that you tried to overcome in the design. I was wondering if you could say a little bit more about how you designed the sequence of the puzzles to try to achieve the educational goals that you had, where the player learns a little bit in each puzzle, and how does that progress over the course of the game?
So we did a lot of playtests to achieve this smooth ramp up for the learning curve, and we use a lot of different things to help we build up this learning journey. We use the dialogues. We also use the did you know tip after every puzzles, and we just kept iterating throughout the semester and adding more puzzles in between every puzzle to make sure we are really building up those knowledge step by step.
Yeah, I've got two quick questions. One is the game looks very polished and interesting in a way that it could stand on its own. Is it possible this could live beyond the competition and be released separately?
So our scenario kind of get a little bit changed this year because so they are hosting, so our client is hosting this year-long platform and they are hosting this game. So this game, even if they don't have the competition, the player can still play this game for the whole year long. And also we are still considering publish this to Steam too as a standalone version, but we are still trying to consulting with the lawyers to see if we can actually do that.
Great. And quick question regarding the AI. What AI system did you use for the artwork?
We use the Stable Diffusion.
Okay, thanks.
Any more? I'll ask a question. What worked well about the AI art generation? What didn't work well?
in my opinion, I think it's like you can open the mind that give the artist a lot of inspiration by some basic sentence, even though at first we did not know which direction to go, and after generate a batch of image, we can find out some basic idea from this image. Yeah.
Yeah, so as the artist, but I'm not grow up with an artist, so I have no experience with art design stuff. So, but I have an idea in the very beginning for what kind of character we would like to design, and with those texts, we can put them in the AI generation, and they can just give you some inspirations, and I can just edit it with what I want, with something already built up for you. They build up the basic thing for you, and then you can add whatever you want on it.
Hi everyone, we're Team Artisan, and our project is Procedure Generation Pipeline plus Open World with Tang Dynasty. These are our team members, our instructors, our consultant, and subject matter expert. So this project is to design and build a procedure generation pipeline with historical data of the architecture and culture of Tang Dynasty to support related open world game creation. Our team created an interactive demonstration for this pipeline as an example, the Tang Dynasty cityscape. Our implementation tools are Unreal Engine 5 and Houdini FX. So the pipeline is divided into 4 implementation sections or stages. To start with, this is the video trailer. Next, we will follow the logic and sequence of the pipeline to unfold.
So we did some research on the architecture in the Tang Dynasty, and we found that the most unique and important part is actually the roof, because different roofs can indicate different social classes and economic status of the people. So our goal is actually to create an adjustable Houdini digital asset, and that can be adapted to different styles of the building. So the image on the right side is actually what we made in Houdini, and we will show you later how it can be adapted to different looks. So we broke our building down into 3 major building modules: the base and stairs, the roof, and the structure with walls and ornaments. We made them separately and merged them together with the matched positions in Houdini, so all of them can be controlled by the same parameters simultaneously. And for the building modules, we actually have 2 different types of meshes: the stretchable meshes and the static meshes. Stretchable meshes means that when we change the parameters, the size of the meshes will actually be changed too, and all of them were made in Houdini by nodes and codes. The static meshes means that we only need them to increase or decrease the number or change the position instead of changing the dimensions. So we have 2 static meshes in the single building. One is the Dogong structure under the roof, and the other is the Chiwen structure on the top of the roof. They were created in 3D software and imported into Houdini to be used. I will invite Eliza to talk more about our single building.
So for the single building part, this is an overview of how we iterate our buildings from half version toward our final version. As you can see here, we updated everything both aesthetically and historically. For the roof, we added the thickness and curve control to make it more art directable. And we also added stairs, 指纹, and more decorations. One important thing we do consider for our HDA tool is the parameter control. As you can see here, we assume that our users might want to input some unexpected result to produce some unexpected architectures. So we make some range control. If our users only using the slider that we provide, they will produce only normal, regular-looking buildings. However, if they want some fantasy-looking structures, like showing in these pictures, they can still technically do that by inputting the parameter numbers themselves. This is the overview of our HDA tool. As you can see here, the parameter contains the controls for roof, stairs, and the structures. You can do this adjustment either in Houdini or in Unreal 5. First, you decide the overall size of the building, and secondly, you decide the architectural elements separately in these different parameters. All the textures and structures will follow up as you make any changes, so it's a pretty interactive tool. These are the different looks that our architecture tools can achieve. So whatever changes you made here, you can decide whether to include some of the architectural elements to achieve different economic status. For example, if you want simple versions of a house for a normal residential area, you can decide not to have the 指纹 or the stairs. And you can decide your own textures. And these are our handmade architectures. Because of time constraint here, we have to handmade some of these. This is a pagoda referencing to Kaiyuan Temple. It is a Tang Dynasty Buddhist temple, and because Buddhist culture was such an important element at that time, we decided to bring them in as an important landmark. Another asset we brought in is the city gate. Here we are referencing to Mingde Gate, which was built right before Tang Dynasty, but continued to be used during that time. It was one of the largest city gate, and also the only one with 5 entrances. So I think it's also pretty meaningful to bring this into our map.
From now on, we enter the second half of the pipeline, building clusters and placement. The second half can be summarized as the basic unit blocks of 1 by 1 and 1 by 2 are first prefabricated manually, and ShapeGramma uses these prefabricated basic unit blocks to generate larger blocks, such as 2 by 2 and 2 by 3. And finally, the entire city layout is generated by the placement methods. So these are 1 by 2. And these are one by one. All of these blocks are available in both rich vegetation and sparse vegetation variants to quickly adapt to different generation styles. And this display level shows all the prepared and ready to use basic unit blocks. Then these blocks start working with shape grammar.
Thank you. So after we have all the pre-made cluster unit, our next question is how to lay out this asset. And our solution is to use shape grammar, which defines a specific class of generation system that can procedurally generate this block. And this, we also augment this technique by using our layout design, and we call it layered shape grammar. And it can automatically select the unit to place into a defined cluster. And it can also guarantee that the generation is valid and directed. And let's look at how we utilize this technique. So first, we will label all of our cluster unit by their size, type, and variant of the type. And currently, we have 3 types of unit that are brick, grass, and no tree. Moreover, we also have another category of label to represent the shape grammar block for layered generation. Second, we will define the generation grammar for the basic unit, layer unit, and also the special unit. And our system will look into the map, and for each mapped pattern, it will randomly select the unit to generate. Here are 2 examples of a 2x2 cluster generation. As you can see that the first one generates 2 1x2 grid to fill the cluster. And the second one generates 2 1x1 grid followed by a 1x2 grid. And we will show more examples in the later slides. Next, I would like to talk about our progress for the placement. First of all, the environment layout tool, which are row tool, wall tool, and terrain tool. And the procedural logic for these tools are developed in the Houdini engine, and we use the tool by feeding them the procedural input from the Unreal Engine. So since we have updated the wall tool and terrain tool regarding their stability, and also their efficiency. Also, we let the users to have more customized options when using our tool. In this video, you can see the usage of our tool. Next, I would like to talk about the terrain tool. To use the tool, a user can use a spline to depict the river, and also use a box to define the flat surface area. Then, the tool will use the data to calculate the shape of the terrain. Then you can change the configuration of the terrain, such as noise scale, river width, and also randomness. After that, we will bake the static mesh and also rescale the terrain to the size we need. And we will also apply textures on it. And that finished the creation of the terrain. Next, I will invite Shunan to talk about the city placement after we have the environment.
Thanks, Jamie. So to achieve the goal of generating a city, we need to break down the structure of town city into smaller pieces. Based on the historical research, the basic unit of a town city is called a ward. Each ward contains 16 blocks, and each block is composed of different building clusters. We develop a word generator that defines how a word looks like. User can parameterize different attributes such as the scale, social status, and the function of each block. I'm going to break down the tool in the next few slides. Through the word settings section, user can configure the scale of the word by giving different size of the grid and how wide the street is. Next, user can add different building cluster inputs to the tool, and the block actors will perform the grid filling algorithm to place the clusters in the block grid. Those are the results generated by different inputs. We can see that we can have words in different styles. They can have grid ground, grass ground, with or without trees. Since we use wall and road HDA to generate the mesh, it is very time-consuming to drag the spine and give that input to the HDA. So we automate that process by calculating the spine points positions and give that input to the HDA through scripting. We also added rotation automation to make the building clusters rotating in 4 different directions so that we can achieve diverse look of words. For most of the time, artists want to have some control through the tools, and we developed 2 methods to support art-directed placement. One is shape grammar, and the other is block constraints. The user is able to configure the status range of the block and the status level of the clusters. Clusters can only go into the blocks that fit its status level. Lastly, we developed a city generator to place a set of words at the same time to achieve town city generation. Next, I will invite Yigang to talk about deliverables.
And as our originally planned and anticipated, our final deliverables include the documentation and the interactive demonstration, the Tang Dynasty cityscape. So we drafted all the project development documentation on the team's Notion site and are migrating to the ETC site to make sure that everyone has the permanent access, and we will keep up the maintenance. For the interactive demonstration, as shown in these videos, we can use this procedure generation pipeline to generate a large number of open world demos, offering both day and night previews, as well as the first-person perspective and third-person perspective. That's all. Thank you. We are now open for questions.
Jesse?
In terms of using Unreal 5, were you satisfied with it? Did anything surprise you about using Unreal 5?
I would say Unreal 5 is great. You can see from the lighting, it's super, I mean, it just magically works like that. Also, like, there's not too much difference using Unreal 5 and Unreal 4 if you just doing blueprint scripting. There might some differences, like if you really get into the deeper, like, or the basic structure of the Unreal. And also, for Unreal itself, we found it is very hard to like scripting everything in like C++. So like most of the work are done in Blueprint. I think that's one challenge, yeah. And also like for the Houdini side, we find there's like a couple of challenges, like just like having the Unreal input to the Houdini digital assets, and make the Houdini assets like works in Unreal is like crash all the time, like sometimes, yeah.
Well, I'm curious, what side does it crash on? Is it the Houdini export or the Unreal import?
Unreal. So like it's either very slow, or like sometimes if you're trying to put too much data to the digital asset, it just crash. Like I don't understand, but that's the challenge, yeah.
Thanks. Well, I'm sorry, one more follow-up. How did you fix it?
We make the HDA a little bit simpler. So like the war tool originally is like very calculation intensive, and we just make the calculation simpler. I think Jamie can talk about more.
For example, take the war tool as an example. Our first version is like we create each brick on the wall, and that like if we just build like a short wall, it can like faster create in the Unreal Engine. But if you want to build a long wall, they will like always like if you want to make the static mesh, it will crash. So in the end, we try to like use another version of like a single face wall and use the texture to fill out those details. Yeah, and also that problem also happens in the terrain tool. If we want to make the meshes very detailed and complex, it will like spend about like 1 minute or 2 minutes to calculate those mesh. Yeah, so we have to like lower down those complexity of the art side.
Got it. Thank you.
No problem.
What would you say the biggest difference between your expectations going into the project and the reality of actually doing this?
I would say the reusability. So like original pitch, we probably mentioned a lot of like reusability, but like it's very hard to make generic tools that you just like giving like a bunch of different input and then make entirely different stuff. Like for our current tools, there are some reusable ideas, and also the pipeline, the whole pipeline ideas could be reusable, but the tool itself probably cannot be reusable. Yeah.
Yeah, and the same thing applies to the architectural part too, because some of the logics and calculation is specific to some types of architecture, like how you calculate the roof, or you calculate the different placements of the pillars of stuff. And so we found that probably is more difficult than we expected to, if we want to make a totally different cultural theme with the same Houdini logics, yeah, that will be more difficult than we expected.
Thank you.
Hello, everyone. We're Team Hi. Welcome to our final presentation. Here are our team members: Angela, Cherry, Constanza, and Yuan. We have Michael Crystal as our faculty instructor, and our client are Michael Tarr and Timothy Verstanen from Department of Psychology. So, what our client wants from this semester is that we create a game that serves as a research vehicle for their research on human-AI collaboration. From this research vehicle, they have three main focuses that they want to know the most. First, they want to learn how an agent executes foraging behaviors in a complex environment. Second, they want to learn how an agent executes perceptual learning behavior and classify visual stimuli. Last, they want to learn how does two agents cooperate together and trust each other in the team decision-making process. To achieve the client's goal, we shipped our main deliverable as two-player collaboration game with many features including swappable human and AI agents, and much more. Out of all the possible human and AI collaboration, our main focus in this project is the human-human part of the game. In addition to completing this version, we also implemented a framework and provided documentations for our client to build AI agent later on. Our base game is implemented in Unity, and we're using Photon as our multiplayer service. Our game will be communicating with the AI agent our client built using Socket, and we also built some customizable features like a data generator for them to support the research goal. So the game is called a Bitter Buster. It is set in the background where there is a spreading bitterness that's infecting the candy kingdom, and it's turning some of the sweet candies into bitter candies. The players will then play two roles, Explorer and Selector. Their common goal is to find and diagnose bitter candies so the bitter candies can be treated. To achieve that goal, the Explorer will need to forage in the candy kingdom and trying to find houses of candies, and then send information of candies to Selector. The Selector will then learn the perceptual features of the bitterness, and then use the knowledge to determine, to diagnose bitter candies. So let's take a look into our demo.
After the game starts, the Explorer needs to investigate houses of candies, then submit the information to the Selector for diagnosis. The Selector may then start the diagnosis and learn the perceptual features that lead to bitterness. Both players are using the same score throughout the game. It contains the accuracy of diagnosing and the number of bitter candies that have been saved or missed. Within our game, the selector needs to distinguish between bitter and sweet candies, which is the visual categorization process that our client wants. The explorer, on the other hand, needs to explore the candy kingdom to find the bitter candies, which is exhibiting foraging behavior. As a team, both players need to reach an agreement on leaving the current neighborhood, allowing us to measure trust dynamics, and both players are able to nudge each other's behavior, such as when the selector puts a marker on the map to guide the explorer.
So that's our demo. So in the very first beginning of our semester, we set out metric matrix to prioritize client requirements, prototyping, and gameplay. Therefore, we utilize rapid prototyping as our development cycle. With multiple sprints, we were able to proactively update our game and design and features, and play tests, and communicate with our clients, and iterate upon our findings. Those are the main builds that we had through the whole semester. We participated in many playtest events and gathered abundant valuable feedback from many playtest methods, such as co-design with our players, doing survey, interview them, and then collect some in-game analytics.
So next, I will talk about some game iteration based on our findings. For the first version of our game, we had instructions on paper that were read before the game. Because of this disconnect, players were confused about what they should do, and our scoring method was not clear enough for the players to understand their goal. So to have a smoother onboarding experience, we created in-game tutorial screens with instructions for the game goal, rules, and score. So we also added more UI elements into the game, the info bars that give more information on what the other players doing and more clear scoring on how many bitter candies have been collected. And in this way, players will have a better understanding of the game's mechanics and be able to build a more effective strategy. So our early playtest revealed that Explorer had trouble with foraging, and firstly, the world had few restrictions on the explorer's movement, and they would easily get lost. And also, explorers had trouble finding houses within our colorful neighborhoods. So additionally, when players wanted to swipe neighborhoods, the explorer need to find the exits by themselves. However, they would waste a lot of time looking around and feel frustrated. So we found that many players chose not to leave the their starting neighborhood because of this cost. So we tackled these issues using many different approaches. Firstly, we added barriers and traps for higher navigational complexity, and both these designs allow us to indirectly control the explorer's movement towards the points of interest. Then to make it easier to locate houses, we added mini-map system and a zoom-in feature that gave explorers control over the camera perspective. And on 3D art side, we added mailbox, a door, and windows for every house to make them easier to identify. We also redesigned our world to a circular shape with a common central area. This way, the explorer is able to easily orient themselves and is more likely to swipe the neighborhoods. Finally, once two players both agree to leave, explorer will be teleported to the central area directly without needing to find the exits by themselves. So the next problem was the lack of meaningful explorer gameplay. The explorer had no agency while the selector is diagnosing. Also from our interviews, we found that very few explorers build any strategies that they would just go to nearest houses and interact with the house. So to fix this issue, the first change we made was adding different business levels for each house and in-world mailbox indicators for these levels. So using this, the explorer can build a strategy to maximize the number of bitter candies they find. We also added in support for interweaving gameplay, so the explorer can explore while the selector is selecting the candies. So this, along with the mailbox change, gives the explorer a chance to survey nearby houses and choose the best house to send the information to the selector.
Okay, throughout playtesting, we also noticed some problem on the select side. During the foraging phase, the selector would spend most of the time looking for the explorer on the map and would have little opportunity to do their own surveying of the environment. Also, as they had no additional information about the world, so there was little to no motivation for the explorer, for the selector to guide the explorer movement. To solve the first problem, we added a new feature for the selector. They could now click a button to automatically follow the explorer's movement. For the second problem, we aim to provide additional information for the selector. In our first iteration, we displayed the business distribution of each neighborhood. This way, the selector is encouraged to direct the explorer to neighborhoods with more bitter candies. Through more playtesting, we found that the percentage would often confuse the players. As such, our current iteration will just show the number of bitter candies of different neighborhoods to help the selector to decide which neighborhood to prioritize. And the next finding is about trust dynamics. One of the most important goals of our game is allowing researchers to measure the trust dynamics between the two players. To achieve this, we designed a system that the two players need to agree with each other to leave the current neighborhood. But in our playtest, we found that the players are biased to accept the leaving request without any thinking due to the lack of choice. And there was also noise in our data collection that we won't be able to tell if a player actively ignored or just accidentally missed the leaving request. Our first solution was making the leave request a mandatory pop-up and adding a stay option. In this way, players must make an explicit decision on whether to leave or just stay in the current neighborhood. To add more measurements of team dynamics, we created additional interactions between the two players. The selector can choose to diagnose all digit house found by Explorer, and the Explorer can choose to follow or just ignore the selector's guiding marker. And in this way, so two players can use their own information to just decide whether or not to trust another player's decision making. Finally, in order to make sure that human players could be engaged with our world, so we added some elements about playfulness. This included creating cute animations for our Explorer and adding environment assets such as a water shader and a floaty in the summer neighborhood.
All right, so now that you've heard about our many gameplay changes based on playtest, note that we had to make a lot of gameplay decisions based on our client's requirements as well. For instance, to ensure that we minimize the amount of data noise from their collection, we had to make sure that we reduce the number of surprise events and that we minimize environmental distractions. We also had to account for AI agents and all of the different interactions that we designed to make sure that they were serializable. And also we had to follow good research practices. So even though there were some cases where we could have presented more information, we had to hide that to ensure that they would follow with the experiment design of our clients. We also did a lot more work behind the scenes to make sure that our game would work in the lab. So firstly, both the Explorer and the Selector had to be swappable between human and AI agents, so we had to ensure that they would be able to take inputs from both parties. For our host, we wanted to offer them the flexibility to test their many research questions, so we gave them many different opportunities to configure the game at will. For instance, we provided a JSON configuration file where they could upload this file and also tune different aspects of the game, such as the game running time, the bitterness probability distribution of each neighborhood, and other gameplay settings. From the aspect of data logging, we wanted to make sure any gameplay events that happen between the Explorer and Selector could be logged by the host into a JSON file, and we provided them with a parser where they can parse this into research data. An example of this is shown here, where we have the JSON log file here and some sample visualizations on the right here. So you can see that we can track the Explorer's position, we can track the Selector's accuracy across different rounds, and also the time spent in each neighborhood, overall giving them a better insight of what's going on. Something that we presented in halves was our customized stimuli in the form of candies. So each of these candies has many perceptual features that can be used to categorize them. And what we did was extract the Figma prototype that we showed in halves into their candy components. And to make this more flexible for our clients, we provided them with a Python generator script that allows them to create over 9 million different combinations. This generator is also paired with a categorizer script where they can define the rules for bitterness that could be swapped out as needed, and it will automatically categorize the generated candies into their respective categories. To ensure that our transition to the client is as smooth as possible, we provided many different forms of documentation. This included written artifacts such as a documentation wiki, meeting notes of everything we've discussed over the semester, and also readmes for each of the coding repositories. We also did in-lab playtesting to ensure that our build would run on their machines, and also a golden spike meeting to make sure that they could build and run it on their machines. So our clients weren't able to make it here today, but they were able to provide us with verbal feedback through the form of an interview. Overall, our collaboration this semester was very successful, and we were able to provide them with a tool that could answer their research questions and much more. Finally, I wanted to cover some takeaways that we have from the semester. So most of these can be summarized in these 3 main categories in terms of game design, our process of rapid prototyping, and also our development in making something completely new that none of us had done before.
In summary, our game is a 2-player collaboration game that has a swappable human AI agents, and it serves as a research vehicle for our clients' research on human-AI collaboration. And we also created a data generator to provide some flexibility for them to do different type of experiments. And that's all of our presentation. Thank you guys for listening, and we're open for questions.
Hey, were you actually able to playtest with AI agents? And if so, what did you learn from playtesting with the AI that was different from playtesting with people?
So far, we haven't. So the AI agent development is fully in control from our client. So they, as far as we know, they are contacting some lab in the CMU that are fully engaged in developing AI agents. So far, we haven't got that resource.
I appreciate the discussion of the iteration of the trust mechanic. Given that it's a really central design to the whole project, where do you feel it ended up, and do you feel like it's achieving the goals, or is there more iteration you think this would need?
Yeah, so the question was, how are we measuring trust right now, and then how, has it been achieving the goals that our clients want? So generally, our current mechanics definitely do give us some level of trust through our many playtests. We do see, if the 2 players are wary about the other person's decision, they will actively choose to ignore as what we plan. We do think that there could be other ways to measure trust that we weren't able to capture, but these were the most straightforward ways, and also would allow us to account for AIs as well. Yeah.
To add up, our client also want the interaction to be as simple as possible, so that they can have multiple parameters that measure the trust dynamics from a single interaction in the game. So yeah.
I know you added various obstacles and things to make the navigation task more engaging for humans. I worry a little bit that an AI might struggle trying to navigate your environment. Is your client worried about that?
So most of the environmental barriers are static, so they're in the environment. So that would have been data that the AI would have access to when they're being trained.
Okay.
So from our client's perspective, we think that it should be okay.
Okay, and a small question. The Figma is relatively new to me. I'm curious about the Figma Python connection. Like those candy component shapes, did you generate those? Did Figma generate those? How did that happen?
This pipeline is that I designed and created those shapes and different components of the candy, and then we use Figma to do the first prototype of the generator, which is Figma plugin. And it's actually also written in Python, but then we extracted all the components and put it in the actual Python script without Figma, that we're just using the Python script to generate candies.
Okay, so it's not like you just exported from Figma into Python. You use Figma to prototype, and then you replicated the work in Python once you knew what you wanted.
Yes, and also with a JSON file to identify all the Candy components so that our clients can configure them.
Great, thank you.
It's a little difficult to see, but the Figma prototype, you have to manually click randomize for each of these. So
Yes.
definitely pulling it out was the right idea for our clients.
I have one more.
Question about the trust. So if I'm playing a game with someone, well, did you notice that people will lose trust and then over the course of the game we're able to regain it? Or vice versa? Could trust be adjusted as the game was played?
Usually in our playtest, if two players are on trust of each other, like they're making the contradict decision, from our observation, it's usually that they'll keep doing this instead of trying to regain trust. But we haven't run a rigorous experiments in the lab, so we don't have a rigorous data for that question, but usually from our observation, it's the regain trust is hard to achieve, yeah.
Echoing Constanza, we actually had a lot of instances where, let's say the explorer would notice that the selector was failing a lot, and that would cause them to gradually lose more trust with that player. But again, we have, most of our playtests were run with pairs who were familiar with each other, and that was also another factor that made it a little difficult to measure by ourselves, but one that our clients will definitely be measuring. Thank you so much.
Thank you.
All right, hello everyone. Welcome to Genscape's final presentation. This is our team, and our faculty advisor is Ricardo Washington. So what we ended up exploring was how to create a VR experience that uses visuals and environmental storytelling in order to create an emotional arc, and we set this in a lucid dream. So this emotional arc that we wanted our guests to go on starts in curiosity, then moves on to unsettled or uncomfortable, then into fear, before finally ending in despair. So this is our demo video. It starts off in a VR world where the guest is put into a clinic under the guise of a sleep study, so that we can create this difference between a reality and then the dream that we put them in.
Thank you for agreeing to participate in Genscape's sleep study. We will have you sleep for a brief amount of time. After falling asleep, you will enter a lucid dream. From there, feel free to explore. We will be recording how long you manage to stay lucid while dreaming. Usually, patients find that moving is possible by pointing with their index finger, and pointing with both index fingers would make them go faster. Patients also reported seeing and interacting with items such as papers, clocks, and candles. We believe these may be reality checks, which, when broken, are used to maintain more lucid control over the dream, so keep an eye out for them. We will now begin the study, so please get comfortable. Close your eyes and slowly count backwards from 10. Sweet dreams.
So at this point, we ask the guests to fall asleep, and we send them off from the reality into the dream world. And once they're in this dream world, they're able to interact with things such as candles, papers, and clocks, which act as these reality checks. And these interact with a hidden timer that pushes back the emotional arc to allow them to maintain the part of the curiosity phase longer. It also extends the amount of time that they can spend in the experience altogether. And when they touch a door, such as you just saw, they will move into one of our different rooms. There are 4 different types of rooms total, and each of these is created through survey feedback from through lines that we found for fear. However, right now, they are currently going through the curiosity phase. We wanted it to be bright, nice colors, very inviting. We want them to not feel uncomfortable going around these spaces and just look around, look for reality checks, and explore the space. It's not until later that we want to introduce more we actually had to cut a little bit of this to be able to make the demo fit within this presentation. So right now they're actually in the uncomfortable phase in this lake scene. If we had been able to show the lake scene earlier, you would have seen the sky was brighter, the colors a little bit more friendly, and the soundscape has changed to be a bit more ominous now. You can also see the shadow figures off in the distance, those little like white people that you'll see because of the fog. We also call these TINAs, it's an acronym that we've been referring to the entire time. And these guys are now in a more hunched over, kind of watching you kind of, pose. And now we've moved into fear. It's much darker, the colors have now changed, the soundscape is much more ominous, and the TINAs are actively going after you with poses that are reaching out to grab you. And this kind of repetition from going from room to room will continue until either you are caught by a TINA or you run out of time. And these reality checks, when you use them, you can actually turn back time. If you gather enough of them in a later stage, you can turn it back to all the way to curiosity phase if you had picked up none in the earlier stages. This allows for brief moments of relief, but in the long run, it still allows us to continue with the experience. Now, both whether you run out of time or you are caught, it ends the same way, which we'll see right here.
Wake up.
So we ran out of time. Essentially, that's despair.
Wake up.
Then you're brought back into the real world.
Congratulations, the sleep study is now complete. Did you know that lucid dreams can help unlock hidden fears and traumas as well? Well, if you didn't, now you know. That is all for this study. If you ever feel the need, please arrange for another appointment. We would greatly appreciate more testing. Jinscape thanks you for your participation. Until next time.
And at the very end, we bring another TINA into the real world as a sleep paralysis demon for one last moment of despair before bringing you to the credits. So we came up with this experience after doing playtesting, multiple internal playtests, and 4 external playtests, not including festival. One of the main things that we were looking for was art visuals and whether those hit home. So Justin will be covering art and visual effects next.
Thanks, Caitlin. So based on our emotional arc going from curiosity, unsettling, to fear, we created concept art and concept art for our TINA, based on that corresponding to each emotion. As you can see, there's a gradual color scheme shift, and the TINAs, you can see like their poses slowly changing. So going a little more into TINAs, also known as the temporal invasive nightmare actors, you can see from left to right in 3D the poses that we decided to use. And they were heavily influenced by the weeping angels from Doctor Who, where they start inching towards you in poses whenever you turn around, and when you turn back, they're frozen. And these are just some reference images we looked at for the poses. Going into the art style, we had a 3-stage evolution. We started off with the scribble drawing style when we weren't so sure where we were headed. We didn't really know our emotion or direction. And then when we decided we wanted to hone in on fear, that's when we decided to go with the realistic style, because we believe that the realistic style would make the environment more relatable to the player. But at this point, we didn't get the responses we wanted from our testers. So then we moved to our last style, which was the oil painting style. It's a lot more surreal, and it actually fits our lucid dream theme a lot better. And surprisingly, we got great responses from our testers from this. And these are just some screenshots of our 4 environments. We have the parking lot, using the same oil painting style. We have the cemetery, we have the cave, and of course we have the lake. I think it's the most obvious in this picture. And now moving next is Lachlan talking about our process.
Thanks, Justin. I'm going to talk about a few key ways we iterated since Halves and what we learned from that process. So as Justin mentioned, at Halves, our art style just wasn't working. It was way too realistic, and it was not at all evoking the feeling of a dream for any of our testers. So we went back to our research, gathered new references from faculty suggestions, our own research, and we honed in on this idea of an oil painting in motion. We then looked for games that had implemented something like this successfully and found 1111 Memories Retold. But when we tried to emulate what they had done in their game, we found that their techniques for a flat screen experience did not translate directly to virtual reality. So, as Justin mentioned, we had to come up with our own technique in which we paired quickly swapping paint textures with a shader we wrote to randomly deform the edges of our objects to create the feeling that the scene is constantly being repainted. Everything is constantly in motion. Once we added this effect to all of the objects in our game, testers would say that they felt like they were in a living painting or a living sketchbook without us telling them that that was our intention. And we found that what really made this work was the use of dynamic motion more than the specific style, whether it was a painting or a sketchbook. Adding this motion really gave that feeling of the dream. And we also found it didn't work until we applied it to everything in our game. So consistency of the art style was key. Next, for the effectiveness of our emotions overall, at halves, our emotions had very little staying power, and they did not build to a clear climax or resolution. So we went back to our whiteboard and we mapped out a series of gradual changes that would fold in over the course of the experience to slowly build up these emotions. However, this introduced a new problem. A lot of them were actually way too gradual and subtle for our testers to notice. So we found that we actually needed a mix of both instant effects and gradual effects in every environment, where the overt effects drew attention to the subtle changes. As you can see in this time lapse of all 4 of our environments, in the lake and the cemetery, the sky and the water and the lights and the fog, those colors change very slowly over time. This is a time lapse of 4 minutes. Whereas in the parking lot and the caves, the lights change at predetermined intervals and objects disappear and reappear at those same intervals as the instant changes. In addition, players revisit these rooms very often, giving them natural opportunities to notice what has changed since last time. To solve the climax and resolution problem, we added 2 endings to our game. First, the shocking sudden ending of the dream itself creates a very natural, clear climax moment. But then the second ending, where the dream invades the real world, creates a more lingering, creepy resolution that leaves our players with the type of sort of dread, fear that we were really hoping to evoke. So we learned what was most effective here was we needed to affect our players on both a conscious and subconscious level for the emotional arc to really hit home. And they needed to be able to anticipate that we were building to a clear finale. Finally, for the mechanics and goals that would actually carry our players through this experience, at halves, the goal of our game was very unclear. And so players would often distract themselves by setting their own goals and not really paying attention to the environment. This was difficult to face because we did not really want to explain the purpose of our game to players, but we needed it to be a satisfying experience without giving them that clarity. So what ended up helping us was a combination of just enough direct and indirect control to get them started and then get them into the emotional arc. Our onboarding experience gave clear instructions that your objective is to stay in this dream as long as possible, but we didn't need to over-explain why. Once they're in the dream, we made sure the first thing they saw included all 4 possible types of interactions immediately. The candles, the papers, the clocks, and the doors are all right in front of you when you enter the game, which guides you to your short-term goals of find a door, find a candle. We found that once they had these short-term goals to focus on, players would do that without worrying about why, and then they would get taken into the emotional arc, and they no longer had concerns about the overall purpose. They were just enjoying being in the moment of the experience. Finally, I'll turn it over to Em to talk about sound and our overall takeaways.
Thank you. So another important aspect of our project was sound, which up until halves we hadn't been able to work on or implement. So one obvious challenge that we had was that none of us on this team are sound designers, so we weren't able to compose anything or any tracks for this experience. So, but we couldn't decide to just ignore the sound because we realized that with moments like with the appearance of the Tinas, in order for those moments to really hit or have emphasis, we needed the sound to like build up that emphasis that we wanted. So we decided to focus on utilizing ambient sounds and noises rather than composed tracks. So subtlety with sound also helped with the gradual buildup of the anxiety throughout the experience for the users. We also explored infrasound and how that affects people and layered that in between some of the ambient noises that we used. So we'll wrap up with our final thoughts on our semester and our experience. So for working in VR, one of the things that we realized was that we didn't want the mechanics to get in the way of the overall experience. We realized this through playtesting. We also didn't want to distract the players from the environment, so we established a more simplistic approach with our mechanics and our gameplay. The headset itself also has some limitations which really informed our art style and what we could do with it. There were many lessons learned in relation to creating a fear-based experience. We discovered that persistent dread is more difficult to provoke, but when it's consistently provoked, the effects do last longer. Environmental changes also do increase the feeling of dread throughout the experience. We also discovered that while using common through lines for fear helped widen the experience for multiple users, it did prevent us from using really specific design symbols and other symbolic things in storytelling. So overall, we noticed that by making the setting a dream, we were able to have some mechanics that normally seem like bugs feel really natural to the environment or intentional. Evoking an emotion and keeping that emotion continuing is more challenging than initially anticipated, which guided our design decisions and the art style. Gradual changes to the environment have a more lasting effect than sudden changes, which would slowly dwindle over time, we noticed with our playtesters. So in summary, we are Genscape, and we thank you for coming to our final presentation. We'd also like to thank all the faculty who gave us feedback and our faculty consultant, Ralph. So we are now open for questions.
Few times I played it, I always had the jump scare. You know, the Tina got me. Those Tinas, they get you every time. But was it possible to avoid the Tinas? Like I saw in one of your slides that if you do get out of it, that you come back into, what was it, the tester site or the sleep study site, the Tinas come into that space. I hadn't seen that yet. So do you avoid them at all? Can you avoid them, or do they always get you?
They always get you, regardless of whether or not you run out of time or you are caught. It will end in the same way with all the Tinas in the scene grouping around you and catching you before transporting you off back to the onboarding room.
So it's also a jump scare at the end as well, too?
Yes.
Okay, thank you.
What advice do you have for future student pitch projects that are fairly open, art-driven experiences?
Would the artists like to touch on this?
That is a great question. I mean, as you can see, I think one of the things that's important is really establishing the art style and like really researching why that art style serves the purpose of the project. Because I do think it's really easy to lean into something that you either know really well or have done before, but just because you've done it before, just because you know it well, doesn't mean that that's what actually will serve your, like, the purpose of the project. So I think that would be the most important thing. There are definitely a lot of other things that we looked at and explored, but also just looking at, again, how really subtle changes in the environment or like, again, poses. Like, I think we were probably in our room just like doing these weird poses for a long time, trying to figure out how subtly like these things could work or not. So I think a lot of small details like that are also really important to focus on, but not get so invested in that you don't get anything done.
I think if I could add, just also from a game design perspective on an art-focused project, I think early on I was really tempted to over-design mechanics, and they were getting in the way of the art experience, partly out of sort of a lack of confidence of showing like my work for the semester being like, you don't do a whole lot in the experience, but that's because it supports the art of our experience. Like, so I would say both like not letting mechanics get in the way in the art and being more confident in your own decisions earlier on to guide you.
So how many of the playtesters were not associated with the ETC, not of the ETC, and not repeat testers? Because that last bullet is more powerful if it's fresh people coming in having no clue who you are or what you do.
I would say about 50%. Half of them were outside the ETC and half of them were in the ETC.
And we got a lot of testers at it wasn't a real playtest, but at festival, a lot of outside guests that had no foreknowledge of the experience.
I would say probably the playtesters we had that maybe didn't react as strongly probably were people who were within the ETC. The people we had react more strongly were definitely people that were not within the ETC.
Given where you were at halves, I feel like it's pretty impressive that you managed to get to this point. What was the hardest choices to make as you were trying to figure out how to maybe scope it down and get it more focused as you were moving towards this final version of the game?
There were several very difficult choices that we had to make, particularly after halves. One of them was on the rooms. We initially had intended at halves to have about 5 to 6 rooms, which was cut down to 4, and there were discussions of even cutting it down to 3 and getting rid of the cave at one point. So coming to the decision on what rooms were going to hit the hardest with the emotions that we were going for and the types of fear we wanted, and deciding which ones were the best to convey that was probably one of the harder decisions. That, as well as making the large jump from switching all the texture assets that we had already created into the new oil painting.
I would also like to add that at the beginning, we were kind of conflicted because we were trying to do like an emotional experience, but then, you know, we had something like the theme of a dream, which is random, and there was like this conflict, and finding that compromise, that good middle ground was tough to find, but I think we achieved that here.